Alrighty, today we are talking about empirical formulas. By the end of today, you should be able to know the difference between molecular formulas and empirical formulas, know how to identify an empirical formula given a molecular formula, and being able to calculate an empirical formula. So let's go ahead and get started. So what an empirical formula is, it is the simplest ratio of atoms in a compound. So, if we have compound C2H4, the empirical formula would be CH2. 2 and 4 can both be divided by 2, so we do that to get the simplest ratio. Another example, we have C6O3H12. All of those can be divided by 3, and when we divide those by 3, we get C2O1H4. So that would be an empirical formula, simplest whole ratio. These are called molecular formulas. And our next learning target is how to calculate molecular formulas. But first we have to talk about empirical formulas. So when you are calculating an empirical formula, the first thing you have to do is determine how many moles of each atom are in the compound. So we're going to have grams of a element in a compound, and we got to get it to moles. The way we go from grams to moles, we have to use our molar mass. So grams to moles. So the first part, we're going to be using molar mass. The second thing we have to do is once we have the moles of all of the elements, we have to divide by the smallest number of moles because we're trying to get a whole number ratio. So we divide by the smallest number to get that whole number ratio. And the last thing we do is when we divide by the smallest number, sometimes we don't have whole numbers. And with formulas, you have to have whole numbers. So then we multiply so that all the moles are a whole number. We'll do a problem with that. So let's go ahead and do an example. A compound was found to contain 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. What is the empirical formula? So the first thing we have to do, we got to convert grams into moles using molar mass. So we have 13.5 grams of calcium. We have 10.8 grams of oxygen. And we have 0.675 grams of hydrogen. So we're going to be doing molar mass conversions. So, the molar mass for calcium, when we look on our periodic table, is going to be 40.008 grams per 1 mole. We got to put grams on bottom because we need to get rid of grams. So we'll put 40.08 grams of calcium, gives us 1 mole of calcium. Now, it is very important that you guys include your units. And with your units, it's a very good practice to include what the element is. So that way when we get to part 2 and part 3, it's a little bit easier to not get lost. So we can plug that into our calculator to get our moles of calcium, 13.5 divided by 40.08, and that gives us 0.33 moles of calcium. Now we're going to do the same thing for oxygen, grams to moles. Molar mass of oxygen is 16 grams of oxygen, gives us 1 mole of oxygen. Plug that into our calculator, 10.8 divided by 16, and that gets us 0.675 moles oxygen. The molar mass of hydrogen is 1.008 grams of hydrogen, 1 mole. Plug that into our calculators, 0.675 divided by 1.008, and we get 0.67 moles hydrogen. So that's step 1. Step 2 is divide by the smallest number. So we pick our smallest number, that's 0.33, and we're going to divide everything by 0.33 moles. Zero point 0.33 divided by 0.33 is 1. 0.675 divided by 0.33 is 2.05. And 0.67 divided by 0.33 is 2.03. Now, these are close enough to being whole that we can round fairly easily. You'll want to start multiplying by a number when you get around 0.25. That's about the time you want to do that. So we can rewrite our empirical formula. No need to do number 3. So we're going to have 1 calcium, so Ca1, 2 oxygen, O2, and 2 hydrogens. Now this is a common element compound that you guys have dealt with before. Notice how there's a 2 and a 2. When there's something like oxygen and hydrogen, you can go ahead and pull that 2 out and rewrite it as calcium hydroxide. I'll count that as correct, but by now you should be able to see OH as hydroxide and pull that out. Let's do one more example. If you feel good, go ahead and be done. Don't be dumb. Alright. Calculate the empirical formula if a sample contains 81.8% carbon and 18.2% hydrogen. So now we're given percent mass. So we have the percentage, but we don't have a grams. So what I like to do in this case is I like to assume that we have 100 grams. So assume 100 grams. So we can basically just change this percentage to grams. Should use a different color. Change that to grams, change that to grams. So when you have percentage, just take away the percentage, change it to grams. So then we are given 81.8 grams of carbon and 18.2 grams of hydrogen. We got to get to moles first. So 12.01 grams of carbon gives us 1 mole of carbon. 81.8 divided by 12.01, that gives us 6.8 moles C. Then we have hydrogen, 18.2 grams of hydrogen. We know that there are 1.008 grams of hydrogen in every mole of hydrogen. Plug that into our calculators. 18.2 divided by 1.08. We get 18.1 mole H. Next thing we have to do is divide by the smallest. So in this case, 6.8 is going to be our smallest number. So we're going to divide by 6.8. That gives us 1. Divide this by 6.8. And let's do that. 6.8. And that gives us 2.65. Now, 2.65 is not a whole number, so what we have to do, we have to multiply and until 2.65 is a whole number. So you can just start at 2 and work your way up. So 2.65 times 2, that's not a whole number either. So we'll do 2.65 times 3. That's pretty close to a whole number. So that's 7.95. So we're going to go ahead and round that up to 8. So now when we times this by 3, we're going to have to times this by 3 as well. Extend the page. So 1 times 3 is 3, so that means we have 3 carbons, and 2.65 times 3 is 8, so that means we have 8 hydrogens. And that is how you calculate empirical formula. If you have any questions, you should read the text. It should be directly above the link to the video. There's some great examples and it kind of walks you through it if this video doesn't help or if you still need some extra help.